Hello, everyone. So today we're going to go one further chapter into taking a look at the normal curve that we've been taking a look at. So today is essentially we're just looking at one concept and we're looking at it in a few different ways. So we're taking the whole idea of the whole normal distribution we're taking a look at throughout the semester so far, and taking the things that we've learned about the variability or the differences between both ends, and also we've learned about the central tendency or the similarities in the middle. So we're taking all these things together and exploiting one further aspect of the normal curve in order to answer questions. So as we talked about, normal curves are something that if you collect enough information on any sort of natural thing, um, any sort of statistic, with enough information, it tends to start to look like this. So for instance, I've given the example of height before. If you were to go around and get everyone's height in the college, in the country, eventually, once you start getting enough people, it's going to start following along the lines of this curve. You're going to start getting certain patterns that are going to start to emerge where the majority of people are here in the middle. And there's going to be outliers on the end, whether it's exceptionally for shorter folks or higher or taller folks. It's going to be fewer of those two groups on the other end. So thus far, we've only been able to kind of estimate that a certain amount is supposed to be on either side. So today we're going to take a look to see how we could look at these formulas, how we could look at the curve in order to determine like an exact number. So given a few things that we could start assuming on normal distributions, we could start making predictions and start actually getting a precise number based on this curve that we take a look at. Okay, so uh, one thing before we jump down into some of these characteristics is normal distributions themselves. It's a theoretical idea, meaning that even though things start to look this way, things aren't exactly ever going to exactly be normally distributed. There's always going to be a slightly off. But the idea is they're so close that we just assume that it follows this pattern, so we can start actually making statistical determinations on things. So technically, nothing follows this curve perfectly, but it's close enough that we're able to actually make some predictions off of it. Okay, so let's go down and look at some characteristics. This would be important. So one of the things I'm going to take a look at as we take a look at this normal curve, let's clear it up a little bit. So as you look here, we see this normal curve, and we see in the middle, the mean, median, mode are all the same. So that's a unique feature of it, a perfectly symmetrical. So that meaning that this side and this side are exactly the same percentage. Each one is 50%. So if we start making those assumptions, there's a few things that we know. So first thing we know, exactly half the observations on one side of the curve and exactly half on the other. So no matter what you're talking about, if you're talking about standardized test scores, 50% of the students scored on this side, 50% of the students on this side. Same thing with height and weight. Anything we're putting on this scale is going to look like that. Further, at the midpoint, so we're talking about this middle point right here, you will have the maximum frequency. And if you recall, that's the mode, the maximum frequency with the highest frequency. You also have the median, and remember median is exactly the 50% mark. And you also have the mean, so the average will also be here. So that's a unique thing we're going to take a look at. So just to pause and think about that, that all these things are going to be the same, mean, median, and mode. So if you were to get a question, something like if this midpoint was, say, 50, that would mean the mean is 50, so is the median, and so is the mode. They're all going to be exactly the same number because on a perfect normal curve, everything is symmetrical, and mean, median, and mode are all going to be the same number. So that's a given. Okay. And again, like I said, they're just theoretical ideas, meaning that nothing is perfectly distributed like a normal curve, but like I said, most things are close enough to make some interesting predictions. So as far as we're concerned for our class, we're just going to assume that normally distributed means perfectly distributed, even though back in our mind, we'll know that this isn't always going to be the case. Okay, so let's break this down one more time. So this one looks a little bit more complicated. It is basically just taking what we saw in the last one, one step further. So I'm going to go side by side here. Say this is the last one, our normal curve, and we had our little mean, median, and mode here at the bottom. So this is our 50% mark, if we remember that as well. So this is all this is saying, is it could be broken up even further. So if we know this is 50% right here, then we could also start knowing, we could also break this up into thirds. So that's all we're really doing. That's what this thing is depicting, is then we start knowing, and again, because it's symmetrical, this distance right here is going to be the same as this distance right here. This distance right here is going to be the same as this one here. And this final one is going to be the same here. So I'll go do the same marks over here. Go start seeing that these two are the same, as well as these two, as well as these two. So what that starts saying is, because we know then that certain amount are going to be exactly in the middle, we could actually start predicting exactly what percentage, now that's what these percentages are talking about, what percentage of observations fall in between those two lines. So this is, again, this goes for anything that's normally distributed. So if something falls on a normal curve, we could say this exact same thing for every single one of them. So meaning that with each one of these little lines here, you know exactly what percentage of things are going to follow. And how this connects to what we've been talking about so far is each one of these lines along our normal curve is a standard deviation. Each one of these is a standard deviation. Oops. So each one of these little tick marks is one standard deviation. So this one right here is one standard deviation, this is 2, and this is 3, and it goes so on and so forth. Technically, it goes on almost infinitely. The same thing on this end. This is also 1. This is also 2, and this is 3. So as you see, they're symmetrical, so the distance between these are all going to be the same. The only difference is as you start going to the left, this is negative, and this is positive on the right. So positive 1, positive 2, positive 3. So you start seeing then these standard deviations we learned about. So when you have a standard deviation of 1, for instance, so if you say my standard deviation equals 1 standard deviation, that would be right here on our map. Right along here on our map. So that's 1 standard deviation. And if you had 2, this is 2 standard deviations. So these numbers directly correspond with what we're talking about on our curve. Okay, so why are we going into so much detail on this? Because we also want to be able to start looking at these percentages, because that starts becoming important as well. So here you can see 34.13%. That's the exact number that's always going to be there with 1 standard deviation. This little section right here, 1 standard deviation forward, ahead of the midpoint is going to be 34.13%. Same exact thing on this side, just the negative side. But the percentage is still going to be positive. So this is 34.13% on that side. So what they're trying to show you here on the picture is showing it's 34.13% on both sides, but if you add them together, within 1 standard deviation, plus or minus, 68% of it is covered. Same thing with 2. Within 2 is 95.46%, and within 3 is 99.72%. So you start seeing that once you get to 3 standard deviations, you've got 99% of all the observations are going to be within 3 standard deviations. So most of the time you're going to be working with z-scores plus or minus 3. So given those things, I'll go down here. Again, 100% of observations lie below the curve. So that means along this our normal curve, 100% of things fall in between it. And you can break that down subsequently within 3, 99.72, within 2, 95.46, and within 1, 68.26. And you see within the 1, the majority of it falls within that first standard deviation. And again, 50% is on the right, 50% is on the left. So given all these numbers, you could technically go in, and if you were to look at this, calculate exactly, if you got, for instance, a 1.55 standard deviations, you could know that you're somewhere, you're going to be somewhere like along this line right here. However, to get the exact percentage of what that is, mathematicians have already made a easy to use chart for us to take a look at. So instead of every single time if you had a question like 1.55 standard deviations, if you had that question, what percentage of things fall between that? If you don't have to take out a graph and start drawing on a map like this, all you have to do is look up something called a z-score. You should write that in. Z-score. And really all a z-score is, it was a mathematician's shortcut to look up all these little points within 2 decimal places to look up the percentage for each one of these. So it was a shortcut rather than trying to say, oh, let's go do the math every single time. Somebody said, well, since it's going to be the same every single time, let's just make a chart. So the chart basically goes from -4 standard deviations all the way to 4 standard deviations. It technically goes beyond that, and we'll look at that a little bit. But generally, you're not going to have much more, because as we said, most of the things fall within 3. And when you say standard deviations, the chart is going to be called a z-score. So -4 z-score all the way to +4 z-score. It's important for you to keep in mind they call it a z-score because it's the special chart. But essentially, one z-score is the same thing as 1 standard deviation. It's just called a z-score because it's on the z-chart. It's just to make our lives easier. So when we say a z-score, everybody knows we're talking about standard deviations. Okay. So now that we have this is going to be the foundations. We'll put this into practice right now. Basically, then, because you have this, you have the ability to use the z-scores to start answering questions about distributions. So I will have a link below, but if you it's just this, ztable.com, z-table.com, and actually pull up a website that I took these images from. So it's in the back of your book if you got the book, but this chart will have the same idea. And I find actually this table to be a little bit easier to use. So let's take a look at this table real quick. So if you look at this table, it's split into 2. As you can see here, there's the negatives. These are negative z-scores, and I'll scroll down to the other side. These are positive z-scores. And all it's really saying here is whatever z-score you get, you can look up what percentage of your normal curve is covering it. So for instance, up here it's kind of indicating this z-score you get is covering this portion. So whatever your z-score is, it's covering this shaded percentage. So these little spots here refer to percentages of the overall curve. And I'll show you what I mean in a second. So say, for instance, you got a z-score of -1.83. So I'm going to go ahead and look at this column first and scroll down until I see the first part, 1.8. That's going to be in this column. And the second part, this 3, is going to be along here. Okay, so I'll show you what I mean. So 1.83, first I'm looking for these first 2, -1.8. So I'm scrolling all the way down until I see -1.8, and it's right here. So you can see these first 2 numbers match. And now I'm going to go look for that third number, the 3. So basically I'm going to go this way until I match up with the 3. And so I'm going up to here. So I'm going along here, and this is where it intersects. So as you can see, the 1.8 matches this part. Make sure you see the negative. And the 3 matches this part. So what does this number mean? So now we see we've got a number. So 1.83 converts to 0.0336. That's the number I looked up over here. And all that is saying is that is a decimal version of the percentage of the curve. So I'll show you what I mean. It's always referring to this curve up top. So basically it's saying that this area is 0.0336% or decimal place of the overall curve. So because this is a decimal point, whenever you want to turn this into a percentage, to convert into percentage, all you do is times it by 100. So that just means it's going to be 0.3.36. And whenever you're doing 100, you're basically just moving over 2 decimal spots. So you can see this one just becomes this one, meaning 3.36%. So what's that telling us then is that if you got the z-score of negative 1.83 or negative 1.83 standard deviations, you're covering 3.36% of that curve. So here's our curve again. And again, you're split down the middle. That means you're just doing this little tiny bit over here. The negative 1.83 is just this little tiny spot, which is equivalent to 3.36%. Okay? So I'll do one more. Let's go down to the positive end of things. So again, what if our z-score then was something like 1 point, actually let's do 2.33. So again, we're going to look for these first two, 2.3, along this part, and then we're going to look for the second one along this part. Okay. So first, let's look for the 2.3. So I scroll down until I see that. I found it right here. You can see the 2.3 matches this 2.3. And then we're going to go along this way until we find that other 3. In this case, that 3 is up here. So this is going to go down. To here. So this is the intersection between the two, the 2.3 and the 3 from up here. So then you have the number 0.9901. So this one becomes 0.9901. And if we want to make that into percentage, we move this over 2 decimal places or multiply it by 100. We get 99.01%. Meaning that with the z-score of 2.3, it's covering 99% of this, of our normal curve here. So it's going to be way over here. It's going to be covering this whole area, that 99%. Okay, so we'll keep on practicing with that, and I'll show you a few more. But the basic idea is we're going to be using the z-chart, and throughout the semester we'll be using different types of charts, but they're all the same idea. They're all based off the normal curve, and they're just a way to get a shortcut to get the percentages, rather than having to do the full math problem every time. Okay. So this is z-scores, and don't worry if you're not familiar with it now. We'll get a lot more practice with that as we move forward. Okay, so now that we've looked at the z-scores, the z-table, what can we do with them? So because of these unique characteristics, like I said, we could begin describing the characteristics of larger bodies of data and start describing them in ways that we could start, like we've talked about this whole time, making sense of the information. So basically, we're only looking at 2 different formulas this time, and there's going to be about 5 different ways that the question might be asked. So I'm going to go through each type, and basically as I'm going through them, just kind of keep track of the steps, because in the homework problems there's going to be like an equivalent of each type of question. Okay, so this is the basic z-score formula. So as we go through, maybe take notes. So all this is really saying the z-score is the thing we've been looking at, and all the y is the score, just the regular the score, and this could also be like height, whatever you're actually interested in. And again, the one with the line on top, this is the average or mean. And finally, S is just the standard deviation. Standard deviation. So each of the problems are going to have all the information you need. So it's basically just you look up the charts and you start filling in each little problem as you get it. So it's just basically trying to fill in this equation. So type 1. So before we go in actually asking the question, let's get kind of familiar with what this is showing us. All the questions we're looking at now are going to be based off this chart. So basically this is just a chart of SAT scores. It has a total number of test takers here, which will be important for some of the questions. And then it has it broken down into 3 categories: reading, math, and writing, and has the mean and standard deviation for each one of them. So for instance, if I were to ask you what was the mean reading score, you would say 485. What was the standard deviation for the writing? It was 109. Or what is the mean for the math? You could say 501, right? So depending on the question, you're going to be looking into one or more of these sections. Okay, so here we go. Let's scroll down here. So the simple one is saying, okay, what if you got a score of 584 on the writing part of the test? So then we know we're interested in this section here. What was your z-score? Okay, so we can start plugging in the numbers. We instantly know that we have our score of 584. So that is the equivalent of this one. We have this one. And we have the mean, and we know that's from the writing, which is 475. So that's what this one's going to be, 475 right here. And our score of 584 here. And the standard deviation of 109 is here. So you just go ahead and enter it in. So you do 584 minus 475. Go ahead and put that in our calculator and divide by 109. And you'll end up with z equals 1.00. So that would be your answer for this one. A z-score of 1.00 or 1 standard deviation. Okay, so it doesn't ask it for this, but I'm going to go back up and we'll go look this up on our z-chart just to get the practice. So z of 1.0. So let's go ahead and scroll up. We'll just do a quick look at this. Let's actually clear out some of these. Okay, so our z-score of 1.00, let's go ahead and just use this box here. Z of 1.00. So first we look up these first two. We see that right here. And then we go across to see where that second 0 is. In this case, it actually just happens to be right here. So we start seeing that our percentage then would be at 0.8413. And if they're going to ask us then 0.8413, what percentage is that? 2 decimal over 84.13%. So that would be telling us that we got 84.13% of that normal curve filled out. Okay, let's go down here. Okay, so let's see what the next one is. Question type 2. So then, and I highlighted the parts that were different from the previous one, and I have the steps laid out. So for instance, then, if you got a score of 675 on your writing test, what percentage of students above the average did you score? So they're asking us then, if you're looking at your SAT score and you scored a thing of 675 on the writing test, what percentage of students did you score better than? And when they say the mean, we're talking about the average, right? So we'll draw a normal curve again. Remember that the mean is exactly down the middle, 50% is here. So they're asking then, if you got a score of 675, and we know the writing part of the test is 475 here, so 50% of the students, the score of 475 means exactly half the students did worse, exactly half the students did better. So you got a score of 675, so we know then that your score is probably going to be somewhere over here. 675 is here. So they're asking you then, what percentage of students scored better? So they're looking for this little spot here, okay? So let's look that up. So sometimes it's helpful, and you'll see why, to draw it out each time. So we're going to plug our numbers in. We have the score of 675, which is our score. The average is 475, and all I'm doing is taking that from up over here, 475, because it's the writing part of the test, and it's the same thing, the standard deviation of 109. Okay, so if we look those up, you get a z-score of 1.83. So let's all go ahead and go up on top and look that up. 1.83, because we want to find out what percentage that is. So I'm going to scroll back up to our little part up here. So our z-score is 1.83. So let's go ahead and look up those first two. Let's find our 1.8, which is right here. And then we're interested in finding the 3. Oh, again, we found our 3 is the same as before. The 3 is up here. So we're going to scroll down. Let's go down this way. 1.83. So 1.83, we see we have the 0.9664 here. Let's go ahead and take that down first before we convert anything. The 0.9664, that's the decimal one we got. So we'll go down here. So you can see in this step here, we got the 1.83, which is 9.9664. And if I were to convert this to a percentage, 96.64%. So then it's asking us, again, it's asking us what percentage above average do we score? So for instance, then we now have this number, 96.64%. And we know that the middle was 50%. So now you're just going to subtract the two. So you're going to take, because we're again, just so you remember, we're looking for this middle spot right here. So go ahead and go across here, and just a simple subtraction. So 96.64 minus 50% means you got 46.64% higher. So that means if someone was asking you, if you got the score of 675 on the test, you knew that you scored higher than 46.64%. That's the answer of students. 46.64% higher. Okay. So now let's do another one. So this is very similar to the last one. There's going to be one additional step. Okay. So in this case, instead of what percentage, is asking how many students. So be very careful when you're looking at the questions, what exactly they're asking for. So how many students did you score above? So let's actually go back. We'll try this out again. It's asking a very similar thing here. We got 50% here. And we know that score is 475. It's the same as before, 675. And we're looking for this again. And all I did here, and I'll show you where we got these numbers from. So 475. The 475 is coming from here. And the writing portion of the test, we're still using that one. And the 675 is simply the number we scored. You scored on the test. That's what this is. And it's asking for how many students scored above the average. So same thing as before. You go ahead and run the z-table. It'll end up being the same number. I did that on purpose. So 675 minus 475 equals 109. Or divided by 109 equals 1.83. So stay the same thing as before. And we'll go through the steps just for clarity. So z-score of 1.83. So you go ahead and look this up again. It's the same idea. So the z-score of 1.83, right here, 1.83. So again, I scroll down to the 1.8, and I want to see where it intersects with the 3 up here. Scroll down, and we see it's the 0.9664. So we're going to go ahead and take the 0.9664 down to our question. Back here again. So now we know that it's 0.9664, but this time we're going to do one additional step. So they're not asking for percentage, so we're going to get the same thing as before. We got this 46% higher. So we do the same idea as before. We do the 96.64 minus 50. 46.64, but that's still a percentage. So we want to find out exactly how many students that is. So we actually have all the things we need up in the top here. So if we know that 46% of the students scored in between 50% and your score, then you could multiply that number by the total number of test takers, because you're trying to find the score. So we know because it's given to us that 1,108,165 students took it, and we just want to find the 46% of that. So all you're going to do is do your 0.4664, and the reason I wrote it like this instead of the with the decimal in the middle is this is how 46% is going to be written in your calculator. So for the calculator, I write 0.4664 times 1108165. That's the total number of students. And that's going to equal 509,755.9 students. So when they're asking you then, if you got the score of 675, how many students scored above average? 509,000 students did. Okay? So the key thing here, I'll emphasize this a lot, is they're saying how many students, not percentage. So when they're asking many, they're looking for how many as in the number of test takers. So you're always going to do that extra step and look back at the number of test takers. Okay, just two more different versions. So this is the same idea, but rather than saying above the mean, they're asking how many scored above you, above your score. So let's actually draw that out to see what we're saying here. Okay, draw this out. Again, 50%. It's the same idea, so I highlighted the parts that were different. This time we got a score of 750, so we're way up here. So we're way up here. A score of 750 versus the score of 475. And so this time, if you look at the question, got a score of 750 on the writing part of the test. So again, it has us looking at the writing section. How many students scored above your score? So we're not interested this time in looking this way. Rather, we're interested in looking this way, this tiny little spot over here. So it's going to be a very small number. Okay, so we do all the same things we did before, just going to look a little bit differently at the last part. Okay, so here we go again. We're going to follow our formula. So we take our 750. So 750, 750, 750, right? And minus the average of 475, which is this one right here, divided by 109, and the 109 is this standard deviation. And for these, whenever you always use the standard deviation connected with the average. So if it was math, you use the different. So it's always whatever standard deviation is connected with the average. Okay, so we go ahead and plug that in. You get the z of 2.52. So let's go look up that z of 2.52 up on our chart. Okay, so let's erase this one. So this time we're looking at the z-score of 2.52. So we're going to scroll down this way to find our 2.5 and actually find it right here. And then we want to go to 2 on this end. So we want this one here. So scroll down here. Scroll down here until we hit the intersection right here. So 2.52 is going to be 0.9941. So let's go take this number and put it down into our, bring it down to our problem, 0.9941. Okay, so we found this one, that's this step right here. We had 2.52 equals 0.9941 or 99.41%. I should write that down here. Remember, 2 decimal places over, 99.41. And now what we're going to do is similarly as before, we're going to subtract the 50%. I'm sorry. Subtract. We're doing it slightly backwards because the reason we're doing it differently this time. So we know that it's 99.41%. 41%. But again, we're not concerned, if we're looking back, this is why it's helpful to draw it out, we're not concerned with this side, we're concerned with this part right here. So what we want to do then is, since we know 100% is within this one, you're going to take the 100% minus 99.41, and it'll give you a very small number. So 100% is 0.59 percentage. So this would be your percentage points, but again, so we have 0.59%, very small amount of students who scored above, but it's asking how many students, so we're not looking for percentage. It didn't say what percentage of students, it says how many, so we're going to go ahead and multiply it by our total number of test takers. So I'm going over here, I'm just going to plug this into our equation. 0.0059 times 1,000, or 1,110,000. Sorry, 1,108,165. And you're going to get the total number of 6,538 students. So that means that, and you should have a really small number, because remember, we are only looking for this hint, the very little tip there. So if someone were to ask you then, if you got a score of 750 on the writing part of your test, how many students scored above yours? You could say a total of 6,538 students scored above you, because you scored so far along that normal curve. Okay. So one final one here. This is the final question you would have. And this, notice the equation looks a little bit differently, because this time they're going to be missing a different number. So let's see what we say. So this question, and again, in the writing part of the test, what score would you need to be in the top 10% of students? What score would you need to be in the top 10% of students? Okay, so this one then, you don't know what score you have, so you're missing the score part this time instead of the z-score. So we're going to start backwards. So what you're going to be looking up is trying to find the z-score, because you want to plug that z number in so you can finish your equation. Because we actually have this number, we have the average, we know this is 475, and we have the standard deviation, we know that's 109. So we have these two already, so we're missing the z-score. We want to look that up on the table. So where do we look? Because we're in the top 10% of students, and we'll draw this out again. So we know this is 50% here. So we were looking for the top 10%. So we're looking for this one. So this equals 10%. So that means this score here is going to have to be 90%, right? 90% is this area right here. So this 90 is what we're going to want to look up on our z-table. So something closest to 90%. That's what I have written down here. Closest to 90%, or 0.9000. And the reason it's 0.900 is because the z-table isn't in, that's the format the z-table is in. So we want to go back to the z-table and look for something closest to this. So let's go back up here and I'll show you what I'm talking about. Back to our z-table. So rather than starting off over on this area over here, we're going to be looking in the body of this. So I'll show you what I mean. So we're going to be looking in this whole area here for something that looks closest to this, 0.900. So you look around, you try to find the one that's closest. It's not going to be exact. So actually, if you look, it looks like actually these two right here are closest, 0.8997 and 0.9015. And the reason we're actually going to go with this one, because this one's a little bit closer. As you can see, this one's only 0.003 away. So then you go backwards. So rather than you go out this way, you get your first two numbers, 1.2. So our z equals 1.2, and you go up this way for your last number, 8. So I'll do that one more time. So you go this way for your first two. You find that 1.2. So you go ahead and plug that into your square here. 1.2. And then you go up towards the last one to get that third number there, 1.28. So now we know, because we looked up something closest to 90%, that a z-score of 1.28 is what we're going to want to put in. So take that 1.28 back down to our question. So now we have the z-score, our z equals 1.28, and we start plugging things in. So we know that, so it's actually, I'm going to write down the equation here, y equals the mean plus z times our standard deviation. And from the chart, we know that the y, and we have the standard deviation. So let's go back up here. So it's 475 and 109. So 475, we got 109, and we just looked up our z-score, 1.28. So now you just do the math. So y equals 475 plus 139.52. And all I did here is I multiplied these two. And then you do the final addition, y equals 614.52. So that would be the score you would need to be in the top 10%. So you go up here, if you recall, in the writing part of the test, what score would you need to be in the top 10% of students? So right here, in this top 10%, the score right here would be 614.52. So that would be your answer. So go ahead, and some of these seem a little confusing, but they're actually not. There's only really one or two numbers that are missing in each and every equation, and it's just a matter of you trying to be strategic and trying to figure out how to fill those in. So kind of go back through these, and it's only going to be one of two equations, and everything you're going to need is either going to be given to you in your table, or it'll be in your z-table. So go ahead and open up ztable.com. I'll have the link below, and go ahead and get started on this.